Thank you for the nice introduction, Dr. Alia, and thank you for inviting me for the conference. I'm very happy to be part of the conference today. Yes, so let me share my screen. Okay, so can you see my share screen clearly? Yeah.
Yes.
Okay.
Yeah, clearly.
Right.
Very clear.
Okay,
Right.
thank you. Yes. Thank you again. So my topic today is about Internet of Things and smart grid cybersecurity. So the outline of my topic, I will talk a bit about the introduction of the topic, and then a bit introduction on IoT, Internet of Things, and also to industrial IoT. And we'll talk about IoT-based smart grid and discuss more recent or renowned attacks, cyber attacks on the IoT and also in smart grid, and some of the challenges and mitigation techniques that to prevent or reduce cyber attacks. So if we look at today's news or in the headlines, so we will see that cyber attack is becoming very more frequent, more complex, and it's harder to defend because they are implementing more advanced and complex techniques. So some of the type of the cyber attacks, for example, like denial of service, like DOS, social engineering or phishing, malware, ransomware, advanced persistence, and that cyber attacks have become like daily news. So especially when we look at this current pandemic. So a lot of, for example, like social engineering and phishing attacks has been happening, and trying to lure people to click on COVID-19 related URL, the website, etc., trying to attract people to give more information about COVID-19, etc. So in fact, actually, a lot of successful cyber attacks has been due to this phishing attack. And a lot of data has been generated on like in the last decades. So to 5 billion gigabytes of data has been generated on a daily basis in 2012, but in 2020, we expect it to have 1.7 billion new information. So cybersecurity that we will discuss today is about the set of technologies and process designed to protect networks, computers, program from attack, damage, and unauthorized access. So when we discuss about the IoT, so Internet of Things is all around us actually. So in basically any devices or object equipped with sensors which can exchange information through the network without human intervention, they can categorize or group as classified as IoT, even though since the term coined in 1999. So there's a lot of definition about IoT, but this is probably the kind of like general definition of the IoT. So IoT communicate device to another device or connect machine to machine directly without human intervention. They can exchange information between devices, etc. So today IoT is basically moving into all and every sector, so opening new opportunities and new challenges. IoT application has been used in like smart meters and smart thermostat, smart home, to smart grid and smart cities. With IoT, basically enable physical objects to make from better objects to make better response to environment changes and also make informed decision. So the growth of the machine-to-machine communication over the last decade has provided communication paradigm that has enabled ubiquitous connectivity between devices with the ability to communicate autonomously without human intervention. So IoT has the potential to become one of the most disruptive technologies in decades. IoT enables digital connectivity to devices and sensors to reach almost any places that previously unthinkable. So by 2025, so there's one prediction actually. So there will be 100 billion IoT devices in the world. Well, this is probably more kind of optimistic prediction. There are more less optimistic prediction somewhere else as well. So and various IoT implementation is in place for smart home to smart grid, from e-health to industry 4.0. So IoT is considered as the next step evolution of our current grid networks for the smart grid, especially. So if we look at the industrial control system around us, or the SCADA, supervisory control and data acquisition. So IoT has been implemented in different ICS and SCADA system that been heavily used in national critical infrastructure. For example, from kind of water treatment, in financial institution, in smart grid, also in manufacturing. So this type of IoT is what we call it like industrial IoT, which is a subset of the IoT technologies that implemented to enhance manufacturing and industrial process. The key enabler technology to deliver a comprehensive product structure as demanded by Industry 4.0. Numerous technologies such as AI, big data analytics, cloud computing, blockchain, M2M, robotics, and cybersecurity are embedded into industrial processes in industrial IoT. So IoT also been implemented in smart grid. So smart grid, also known as the next generation of the power grid, is considered as a power grid infrastructure with advanced information and communication technologies, or ICT, that will enhance the efficiency, availability, and reliability of power systems. So various devices are required in smart grid for monitoring, analyzing, and controlling the power grid. The ICT innovations such as IoT play major roles in smart grid to be enabled to enhance the efficiency, availability, and reliability of power systems by supporting various network functions throughout the generation, transmission, distribution, and consumption of the electric power. IoT devices such as sensors, actuators, smart meters have been implemented to monitor various areas in smart grid ecosystem. So as the smart grid is one of the largest and the most complex IoT implementation in the world. So because basically smart grid can potentially connect 100,000 or even millions of IoT devices distributed in very large areas running in different communication protocols, which is give us more challenges that we will discuss later. So the adoption of the IIoT in smart grid can offer benefits, including better capacity for planning, faster service, improved decision making, and enhanced safety and reliability. So when we look at the smart grid architecture, so different with the current power grids. So in smart grids, normally we have like two flows or two lines. We call it like power, like power flow and information flow. So the power flow is like when the power from the generated generator transmission go to distribution. But then for the consumption, because in smart grid we have like a dual, like consumer can also be a producer. And then in information flow, you have this wide area networks and also network, neighborhood area network and the home area networks. So while like will we see in this smart grids basically, so it perform the two-way communication flow between distributor and consumer, like what we see in the figure, while in traditional power grid only has one-way communication flow from distributor to consumer. So unlike traditional power grids, so smart grid also provide on-demand service that able fit to consumer requirements, and then this will kind of bring another challenges in cybersecurity perspective. So in IoT-based smart grids, so IoT is implemented in different areas from monitoring to operation. IoT have been deployed to monitor to the substation, RTU, in smart home, etc. The IoT facilitates a smarter and more connected grid by enabling bidirectional information flow and connectivity throughout the grid infrastructure. Since IoT-based market will consist potentially millions of nodes, it has the largest attack surface for an IoT-focused cyber attack. So will as smart grid or power grids consider critical infrastructure. So any attack on the critical infrastructure will have very big consequences. So in smart grid, like different can be classified into different like classification in terms of availability, integrity, and confidentiality. And for example, if we look at DDoS attacks, so this is if we have like 100 gigabit per second DDoS attack, which is trying to cripple a specific object like smart grid. In 2003, we have less than 100 gigabit per second. In 2020, is around like 12 times of the scale. So, and the impact of cyber attack, they can bring the power down and change, for example, normal frequency like from 50 hertz to 60 hertz, etc. So the two main reasons that make security in IIoT more complex is because currently there is no single standard that defines the IIoT, and there are different standards and regulatory groups that provide specific direction in different segments in IIoT. So some of the example of the cyber attacks in industrial IoT, one of the main cyber attacks is the Stuxnet that attacked Iranian's nuclear power, so destroying uranium enrichment. In 2009 and 2015, we have the black energy malware, the cyber attack on the SCADA system on power grid in Ukraine. Also in 2016, there's attack using in DIN is the service provider, but is also provide service for domain name system with cripple disrupt access to popular websites such as Netflix, PayPal, etc. So they use basically using DDoS attack with using the IoT devices with the Mirai botnet. So this attack is becoming more well, kind of easier for both attackers, basically because there are some other free tools like this showdown. They can basically you can search and disclose more other thing about the IoT devices vulnerabilities and also sensitive information such as IP address, the open ports, etc. So for example, like that one has been used for both, well, white hacker and also the black hacker. So there is many ways the attacks can reach the ICS on SCADA, for example, using the removal media, which is used in the Stuxnet, or phishings and also software vulnerabilities. So ICS has been has been the main target of the malware attacks. So energy, as seen in this graph here. So energy and critical manufacturing, water and wastewater system has been part of the main target. So how we mitigate the cyber attacks? So there are some aspects how to mitigate it. So because new threats are emerging every day, some of which have previously been unknown, making it very hard to eliminate cybersecurity attacks. So there are some mitigation plans. So for example, using access control, encryption, and also authentication, regular security patches and updates, physical security, and also using intrusion detection system like IDS, because if the all above mentioned access control, encryption, etc., are applicable when defending the IoT smart grid against attack initiated by attacker outside the grid. However, if the attacker is already inside the system, so IDS will very useful.
Yeah.
And yeah, okay. So and also kind of like a blockchain, which is kind of electronic distributed ledger, which is popular emerging technology to maintain privacy. So it's been also implemented in smart grids to maintain privacy. So this is like a sample of using the IDS implemented in SCADA. So using the multi-layer, so the compared to traditional SCADA structure, this structure here is divide the normal corporate network into new corporate network, including enterprise server, and then also corporate and DMZ or demilitarized zones. And cyber, and because there's many things that been used as well. So the use of AI or machine learning and cybersecurity also been widely implemented. For example, in they use the support vector machine, for example, to classify different attacks or built using different machine learning techniques. For example, for SCM and KNN to build IDS, intrusion detection system, or use different things, because basically this one of the current trend to mitigate cyber attacks. So there are challenges ahead, and we see in this diagram here. So it's projected rise in number of cyber attacks from 2015 and 2020. So it's about like 2.5 times or almost 3 times cyber attacks has been happening since 2015 to 2020. So in summary, so we see that the IT is moving into virtually every sector, opening new opportunities and new challenges. So we see the IoT application from smart meters to smart grid, and then to smart cities. Smart grid is essential part of the sustainable smart city to ensuring reliability and availability and efficiency of the power grids. Since the IoT-based market will consist potentially millions of nodes, it has the largest attack surface, largest opportunities for the hackers to trying to attack the target, the one as a one of critical infrastructure, because it's one as a one of the critical infrastructure. The consequences will be devastated. And despite of the challenges, the use of IoT is shown to improve the existing grid networks to facilitate better monitoring and control of the power grids. It is therefore it's necessary to focus on the security issues during the different phases of designing of the smart grid, the IoT based markets, implementing and integrating the IoT devices in the smart grid. Okay, thank you very much for the attention.
Okay, thank you very much, Dr. Bernardi Pranggono. How do I call you? Ben or?
Yeah, Bernardi should be fine.
Bernardi, okay. You know, there's this issue is very interesting right now, because in any aspect, IoT is developed very fast. I believe this, including the in the smart grid. By exposing the grid, smart grid, to the IoT, any threats is open wide. I believe something like that. So in the future, of course, the security need to be improved. Now we go to the chat room. We have a question from Dr. Zaini. Today, PV price is getting cheaper and cheaper. What is the role of IoT to manage such distribution generation effectively without causing instability problem in the power grid? Distributed generation, I mean. Okay, please.
Okay, let's see the question. Okay. All right. Okay, so because basically, yes, so the PC price is getting cheaper and cheaper, and there's a role of IoT to manage such distributed generation effectively without causing sublet problem in the power grid. Well, the IoT is supposed to be make it smart grid more efficient and reliable, but because because there is like a kind of the IoT is not from it's from the it's basically is from computer engineering perspective or the electronics side, which is the embedded system. So even though from the as a security researcher, so IoT has been kind of notorious because a lot of issue with IoT. So and with the smart grid actually, because they want to implement the ICT to make it better power grid compared to the traditional power grid. So we kind of need to be aware, and when we designing the or adopting the IoT into a smart grid in every aspect. Like the smart grid has been used in, for example, in the smart home using the smart meter, etc. Which, and then if we look at okay, this diagram here. So basically in this the home area network where there's a lot of IoT devices has been implemented first. So but and then there's also other IoT devices that's been implemented in like a substation, for example, in the remote area. That's also vulnerable to cyber attacks. So when we basically the kind of like a general answer is basically would like to, when we need to as a smart grid engineer, etc., need to adopt the IoT, need to be careful because a lot of IoT doesn't have appropriate or suitable security in place. For example, the main issue with IoT is because when we design IoT, like computer engineering or engineer, etc., so as we want to design IoT because as small as possible and as cheap as possible, and because of the limitation of the hardware, so it is difficult to implement kind of advanced, for example, encryption techniques that normally we can do it in, for example, our mobile phone or laptop. But with IoT devices, some IoT devices less than say $5 or etc. It is difficult. And many IoT devices have been used in cyber attack. For example, in Mirai DDoS attack, distributed DOS attack. So they're coming from a lot of chips, IoT devices that doesn't have suitable encryption, for example. So the people doesn't change their default username and password, etc. So they can be hijacked by the hackers to be part of the botnet system. I hope that kind of answer your question.
Dr. Zaini, any comment from the explanation of Dr. Bernard? Hello? Okay, we can go through the next question, Dr. Bernardi.
Okay.
About the cyber attacks and DOS attacks that carried out all the times, including the smart grid system. How do we know the attack. You may give the explanation about this.
Yes, so how do we detect and overcome those attacks that carried out on smart grid system that have been connected in the IoT system? Do you have to do a system scan, or is another better way? So there is different methods to can be used for detecting DDoS attacks. So because well, DDoS attack is kind of very very hard to defend for the cybersecurity perspective, and this is very hard to defend, and that we see in the in one of the slides. So and we can see is because DDoS basically is very hard to defend, but this is also very easy to generate. So a lot of hackers actually in the black market, they can actually buy to attack specific target, buy from like kind of internet service provider, but it's illegal internet service provider basically. In the UK, there's been one of the kind of teenager hacker has been arrested because of providing this DDoS or this botnet attack to attack specific target. So some of the methods they use to defend DDoS attack is implementing kind of if your for example, if your website is connected to the cloud, so they use the service provided by the cloud, and they can detect basically so using kind of AI or machine learning technology to detect anomaly packets. So if, for example, if they have normal, so they have kind of a baseline traffic. So if there are the normal traffic is say have like a 10 gigabit per second or something, and then suddenly you have this more than 10 gigabit per second. So it's basically the system will raise an alarms and they can do it automatically, or they alert the system administrator to alert about the issues, and they will check if the traffic coming in is genuine or is benign or is malicious kind of attack. So this is basically can be done as in many service provider. They kind of provide this kind of services, but like big companies like Amazon or Google, they have their own system. So yes, DDoS is very hard to defend, and security researchers is looking to use AI to trying to better defend against the DDoS attack. I hope that answer your question.
The question from Mr. Ridwan, yeah, Ahmad Ridwan. Is there any comment or additional question from Ahmad Ridwan regarding with this question?
I think he already answers, so thank you for answering my question. So I should move to next question.
Okay, right.
So,
any research or investigation that implementation of IoT successfully increase reliability of smart grid, may in UK areas especially, if any, how is about its implementation in UK? So Mr. Hasbi Fali wondering about this IoT.
Yes, interesting question, and honestly, actually, I don't have any data actually. So IoT is usually increase the reliability of smart grid in the especially in the UK, but in general actually. So because IoT has been used for to increase the efficiency of the smart grid, that's been used not just in the UK, but mainly also in the US. It's been you can read academic papers about it, and then the and because normally the the convenience and security is not go hand in hand, isn't it? So many people, they trying to use like a simple password, for example, instead of a very complex password. And this complex password, the simple password is basically it's very easy to crack, etc. So the and smart grid in general has been implemented in the UK. So some of the power companies, they implemented smart grid. So in the plan by the government is actually they basically had planned to implement or install the smart meter, which is also part of the smart grid in 50 million household in the UK by 2020. And this was a plan, but actually because of different problems, issues, so the plan has been kind of rescheduled actually, because they admit they cannot install these 50 million smart meters by 2020, which is now it's already in November, so like and only like 2 months time. And yes, so in the UK, it's been slowly implemented in as far as in the UK. Is that hope that answer the question?
Okay, from your explanation, that's in UK, smart grid seem that all of them connected to IoT. In terms of the player, what is a player in smart grid in the UK? Is any household also have a game in smart grid?
Yes, so basically one of the characteristics of smart grid is basically as a consumer, you also can be a producer, like a two-way communication instead of one-way communication. So I don't have like a kind of detailed data actually how many consumer and producer in the UK for this smart grid area. So basically, if they have, for example, like a solar panel, etc. So in theory, basically they can also sell their electricity, the power back to the grid if they have like a surplus, etc. And if also if you have like a kind of private wind turbine, etc. So they can basically sell to the power companies. But this is not really kind of common because, well, as you know, in the UK there is not much solar power, not like in the for example in Australia, which is kind of there's more suitable for solar power, and also in the US. So in the UK, renewable energy, they more using kind of the wind energy, using the wind turbine, etc. Yeah, so that's does that answer your question?
Yeah, you answer my question, but interesting. It's not easy implemented in Indonesia like that, right?
Well, Indonesia actually has big potential actually with
Yeah,
the solar power. But yes, so because this market rely on very good infrastructure, etc., which is yeah, kind of it's yeah, it's even in the UK, it's not easy to implement. Like many people out there, actually, they don't want to, for example, use a smart meter because they think, well, you know, they think smart meter is invasion of the privacy, etc. And there's like a lot of conspiracy theory, like what we heard about conspiracy theory about the 5G implementation regarding with the COVID-19 effects. So this, yeah, even in the UK, actually, many people has this kind of opinions, and they don't want to have smart meters in their home, etc.
Okay, now we go to the next question from Mr. Rohais. He's wondering about the use of cloud services for the small companies. What is your opinion about this?
So most small companies are scared to use cloud services and more comfortable to use local server for their data storage. So this method will expose themselves to the cyber threat, especially when they migrate to smart process. What do you think? Okay, if I clearly understand the question. So cloud computing has many benefits. One of the benefits is actually because they only charge what you're going to use, like pay as you use or pay as you go. So many small and medium companies, they cannot afford to have, for example, abundant resources in computing resources, or they cannot employ, for example, dedicated database administrator, etc., which is very normally it's very expensive, or employ their security engineer. So they turn to use these cloud services, which is, for example, using this AWS in Amazon, etc., which is you can use their services, the cloud, the computing resources, and also the like database administrator, the DPA, the network engineer, security engineer, etc. So in when you need it, and this normally been adopted by many small and medium companies, like in the UK, also in the US, because they can have the same infrastructure that what Amazon has, using when they need it. So they can, for example, if they have like more, if they're selling something in the internet and they have more customers, so they can just increase their what you call it, their usage and increase their capacity. So, but if they have less customer, so less demands or less transaction, so they will decrease the capacity. So they don't need to hire dedicated DPA or security engineer or the expensive hardware by themselves. So they can basically share it with other, they can share it with other small and other medium companies to use the specific, the expensive hardware. and software. But yes, your concern is also you mentioned is also true, because basically when you use cloud, so it means your data is not local, but actually your data is stored in the cloud. So this well, the company need to, when they decided to use the cloud computing services, so they need to think about what data need to store in the cloud, on what data need to store in the local storage. And for small and medium companies, probably it's not that big issues, but for say big companies, and especially for government. So like in the UK, so this government is basically they can't use, for example, use the cloud storage, the cloud services, because of the security issues, if they have like confidential data, etc. So they need to have store it in the local storage. So they, instead of using the public clouds, so they need to use what they call it private cloud. So that's basically kind of the securities security as perspective that you asked in your question. So I hope that
We still have
answer
one
your question.
Maybe the last question, Dr. Bernard.
Okay.
From Mr. Sarkawi Samsudin. The question is, what we have to do for protection our smart grid system?
Well, the general rule of thumbs is basically when the smart grid engineer need to design the smart grid, so they need to think about the security aspect in every layer, in every department. So because security has been kind of not been as a priority area for especially in the industrial control system, etc. So because they think, because they are not connected to outside world, so they do not think about the security aspect. So for example, like when they transmit from sensor to actuators, or from the substation to the SMI and SCADA system, they transfer the data in clear text, for example, because this is because they want to basically transfer data as fast as possible, and they don't worry about the security. But now with this market, basically, because if you connect it to the network, it means your data has a potential security risk. So want to basically need to think about security aspect when you design your smart grid system. So in from when you deploy your substation, or from the generation, or from the smart meter, how they transfer data smart meter to the to the gateway, etc. We're using IoT, because normally IoT have this perception layer, the gateway layer, and the the network layer. So how they transfer the data from its layer, is it transferred securely, or if not, what need to do, because IoT has limitation in terms of kind of encryption and computing resources, etc. I hope. And yeah, so one other thing actually, so one of the issue in the cybersecurity security issue is actually the user awareness and user education is very important. Like a lot of attacks, a lot of cyber attacks can be prevented with the proper or suitable training for the users. So one of the, I don't know if I had it in my slide actually. So one of the research says, so about around 50, I think it's 50-60% cyber attacks for the normal companies, they can be prevented by user training or the suitable user training. Because like what we said, many that I mentioned before, like many successful cyber attacks has been part of using the social engineering, like phishing attacks, like people clicking on the email, the link on the email that looks like, okay, this link from your bank, etc. And they click it because it's the URL. It looks like from the legitimate bank, the website, but actually it's not. So and then they install behind the scene the malware that can give the attacker access not to your computer. Yes, access to your computer, but the main problem, the main issue, the main target is if you are working in critical infrastructure company, for example. So the main target is the companies. So if they can access your computer, so hopefully they can have access to your company's network, and hopefully then they can have access to other more confidential data.
Okay, thank you very much, Dr. Bernardi.
Okay,
now we
thank
come
you.
up to the end of the session. But before that, I want to say Assalamualaikum from Dr. Yosef Rizal, maybe your friend, yeah?
Yeah, Waalaikumsalam warahmatullah. Yes.
Before we close this session, I like to thanks to Dr. Bernardi for very interactive presentation and discussion, hot discussion. Maybe if we continue, still have another discussion, but the time is limited for us. And then also for the audience, I like to thanks, still have 157 audience right now. Even it's not the favorable time for discussion and presentation right now, but I respect what we have done today. So now thank you for your attention, and thank you, Dr. Bernardi. Maybe you have contact with my friend that's interested in with the grid, yeah, maybe through Dr. Nasir Soni or Bu Adrianti. Yeah, very nice, very hot. Then now I return to the host right now. Thank you very much.
Thank you.